Alright guys, in the last video we studied about lemma 2 example, and in this specific lecture I'm gonna give courtesy to my teacher. Okay, and we're gonna conversion of CFG into Chomsky normal form, context free grammar into Chomsky normal form. Okay, why we need to convert from CNF into GNF? To normalize the CGF, or removing the productions of the form A and this epsilon sign and AB to remove recursion property of productions. No standard form complex for processing. For effective processing, we convert CFG to CNF. So basically, for the efficiency process, we convert our context-free grammar into Chomsky normal form. Now back in, if you study databases, it's a similar concept to that you have almost tons of data, and then you normalize that data into a simple form up to 5NF. So you can relate with this thing with that, although it's completely different, entirely different. And if you do not have the idea of the database, I must say that you should ignore and focus on this thing right now. It's basically tons of data being simplified into simple data. Okay, so context-free grammar, Chomsky normal form. Chomsky normal form, in formal language theory, a context-free grammar G is said to be Chomsky normal form, first described by Noam Chomsky. If all the production rules are from A can be replaced by BC, or A can be replaced by E, and starting point can be replaced by empty set. So these are pretty much your conversion steps. The conversion steps to Chomsky normal forms have four main steps. Get rid of all empty productions, get rid of all productions where RHS is one variable, replace every production that is long by shorter production, move all terminal productions where RHS is one terminal. Now before focusing on these four rules, I'm just focused right now over here. Forget all this. Now from 9th class, if you remember, we draw this 11011011, this truth table. Keep this truth table in your mind. Okay, so determine the nullable variables, those that generate empty algorithm given earlier. Go through all productions, and for each omit every possible subset of nullable variables. For example, if P A X B with both A and B nullable in productions, P can be replaced by XP and this. Now if you relate this thing with that truth table, after this delete all productions with empty RHS. Now just focus on this thing. So what is happening over here, this is your P, and P null B with both A and B is possible at productions P null B, or B becomes null, and then A is with null, and this null turns into a null set, that is X. Now personally I am also studying this for the first time, so I'm gonna having a tough time making this video, but let's just together solve this thing. Eliminate variable unit productions. A unit production is where RHS has only one symbol. Consider production A B, then for every production B is tends to alpha. Add the production A tends to B, repeat until done, but don't recreate a unit production already deleted. Replace long productions by shorter ones. For example, if you have a production A and BCD, then replace it with A BE, either BE and E with CD. Okay, A with BE and E with CD. See, A with your BE and E will have your CD over here, and B and E. So it's kind of like tree. In theory, this introduces many new variables, but one can reuse variables if careful. Move terminals to unit productions. For every terminal on the right, for a non-unit production, add the substitute variable. For example, replace production A tends to B. A can be replaced by BC with productions A, B, C, and B can be further become small b, which is any small letter is the leaf of any tree. Okay, now forget about, for if you didn't understand that, forget these steps and focus on this example. Consider the Chomsky context-free grammar S. This is having AX and BX. X is having AY and then BY and an empty set, and Y is being replaced by X and an empty non-terminal terminal. Okay, so your small alphabets are your terminals, your leaves, which cannot be extended, and all your non-terminals are your capital alphabets from previous lectures. Okay, then where do we have this question over here? And then step 1 comes in. The variable x is nullable, and so therefore is y. After elimination of the empty set, we obtain this thing. See, s is eliminated as, we have this s over here and x over here and y. S is replaced by, if you look at this truth table and look back over here, then x, this 1 1 0 1 1 0 and 0 0. So your ax and bx is reduced to your ab, which are your terminals. Okay, and then similarly x is replaced by ay, by and ab. Okay, 1 along with this and b along with this, and then a and b. Okay, now what do we have is x, y is being replaced by c, and that is our step 1. Now if you look at the step 2, after elimination of unit productions, y becomes x, y is replaced by x. We have this form over here. The first form is the same, and then your x is over here, so x will be, look at here carefully. You have this ABC over here, and if you look at this step, you have this this thing that y can be replaced by x over here. And just look at this step back again. Now just focus. These two steps are untouched. Okay, and now what we did was we have let me just scroll down a bit to the perfect position. There you go. Okay, see, this a, b and c is all put together over here, and this is ay and by. Well, this ay and by was actually, it was actually x over here, and x can be, what was the value of x? The value of x was this. So this is pretty much here, this thing. Okay, that's step 3 and 4. Now break up the RHS of s and replace a by capital A, b by b, and c by capital C wherever non-units. Now watch carefully. This ax is being replaced by e, and this bx is being replaced by f, and this particular, this af is replaced by, okay, so this bx is your f, and this a is your a, and this b, small b, is your b, and this e is your ax, and then ab or ab, according to this rule. If you look at this rule over here, this comes over here. Okay, and then you have your x over here, ay, this is a and this is y, this is b and this is y, and this is a and b. Okay, now if you look at y, a, capital A, small a is replaced by ay, this b is replaced by capital by, and abc are in this way. Okay, and e is replaced by ax, and f can be replaced by bx, and a, according to this rule, can be replaced by a, b, and c. See, I was correct. E was replaced by ax, and f was replaced by bx, f was replaced by bx. Okay, now that was pretty much your normalized form, Chomsky normalized form. Now if you want to practice this thing, you can practice this thing, and solution is right over here. Okay, so I'm gonna see you guys in the next video.